Yeah, okay. So, hello everyone. My name is Deepak Chetan. I'm also called as dodococo on Telegram. So, when the RSOC thing began, I was in my final year of computer science. Also, I'm from India, South India to be exact. So, I've been an active contributor to Radare 2 since December of 2018. So I've been making small minor contributions to it since December. So initially I wanted to get into GSOC as for Radare only. So I contributed to it from February and I completed the micro tasks as well. But then GSOC wasn't selected. So then I moved on to applying for RSOC and then I got selected into console interface improvements. So my actual work started in August. From then I've been working on like 6 or 7 tasks. Can we go on to the next slide?
Sure, we are in the main goals slide now.
Yeah, okay. So in my proposal, I've actually applied to complete 7 tasks actually. All the tasks are listed over here. The first one is generalizing the code pop-up widget and then improving auto completion. Similar to this, I have like 4 other tasks which I've actually tried to complete except for one. I was not able to complete the table commands actually. So can we go on to the next slide? Hello.
Yeah, we did.
Wait.
We did.
Yeah, okay. So the first task was to generalize the code of the pop-up widget. Actually, there was a pop-up widget already in Radare 2, but it was only used in the visual offset mode. So when you type in G command in the visual mode, you can see a visual pop-up. So that was only used in one place. So the main task here was to extract the code and use it in multiple places. So I had to refactor the code and then integrate it into the r2cons of the DEETLINE. So after doing that, it was actually useful for showing the auto completion options in the normal DEETLINE. So this feature can be enabled by toggling the config variable called ser prompt.popup. So if you enable this pop-up and then try to use tab to get the auto completion, you can see the pop-up widget to display all the auto completion options. So if you go to the next slide, we can see the actual working of the pop-up. So here on typing echo and then typing the tab, we can see all the auto completion options, the various themes listed over here. So yeah, it works for all the other auto completion as well. So this was my first task, and yeah, can we move on to the next?
I mean the task 2, to completion improvements.
Yeah, auto completion improvement. So auto completion of improvements we did several parts. So the first part was the work in the mount shell. Yeah, I'm hearing the echoes again. Yeah, so the mount shell was actually using its own version of input behavior. So I had to replace it with DEETLINE so that it can use the auto completion. So even after replacing with the DEETLINE, we had to use a different mode in order to make it work exclusively for mount shell. Since mount shell was using different commands compared to the actual Radare 2 commands, this was necessary. So a bit of refactoring was done in the r2con's auto completion as well. So yeah, and then we integrated the refactored r2con auto completion with the mount shell so that it could be used in mount shell as well. So apart from that, all the mount based commands, that the yum based commands did not have the auto completion. So auto completion was added for all of these mount based commands also. So these commands are like mg, mc, mo, etc. are similar to this. Okay, can we go on to the next slide?
Yep. And auto-completion improvements added SDB auto-completion.
Yeah. So the next stage of the auto completion was adding auto completion for K command. So K command is mostly used to show the SGB auto completion. So if you can see in the screenshot, the K command and then tab press actually shows you all the different SGB spaces and then the actual SGB keys with the values as well. If you type in enter, it will go to the and select that particular SGB key, and again on pressing enter, it will show you the value as well. So this was the second task in the auto completion improvements. Can we go on to the next slide?
Yep. There is a live demo on the mount shell and K auto completion. I've been doing some demos while you were explaining, also showing the slides. That's okay.
Okay.
Task 3, improving DEETLINE modes.
So in the task 3, So in the task tree, again this task could be separated into several different parts. So the idea was to make the Radare 2 shell similar to the actual Unix shell. So I had to add a few of the commands that were not already present in Radare 2. So most of these commands work similar to the Unix, but some of them were modified. The syntax was modified in order to make it work over here. So so the commands that I implemented are unique, which shows only the unique keys in a given file, and then sort, like the name says, it just sorts the text in the file, and then join. It will join two particular files and outputs them into the std out, and then head takes in one more parameter n and gives out that number of lines, which is similar to the Unix command, and then the same goes for the tail as well. It gives the last lines only. Can we go to the next slide?
Yep. And the task 3, improving DEETLINE modes.
Okay. So this is the second stage of my work on DEETLINE modes. This mainly involved adding new key bindings for Emacs, which I did initially. After I was done with those, I moved on to creating a VI mode, using which we can enable VI key bindings on Radare 2. To use V mode, you should just toggle the SCR VI to true, and once you are done with that, when you press the escape key, it will go into the command mode. So in the command mode, you can use most of the VI commands that are actually displayed in the current slide only. So you can insert, delete, and do all of the other stuff. So one major challenge was making it go into the control mode and then coming back into the insert mode, because the escape key was already being used to do a lot of other things in various other submodules like HUD and stuff. So I had to replace and refactor those things before finalizing the current implementation that we have today. So yeah, it supports most of the VI-based key bindings that are actually used in Unix shell as well. Yeah, so this is not the default mode. The default mode is the Emacs one. So in order to toggle it and use it on your machine, you should enable the toggle. Yeah, that's it. Next slide, please.
Okay, gravy. Improvement in dialect modes, integrated dialect
Task.
Yeah.
Yeah. So the next set of action was to integrate the already existing DEETLINE mode into the HUD mode. So the HUD was actually using its own version of input taking. So that had to be completely replaced by the DEETLINE. So by doing this, I was able to get all the Emacs and VI based key bindings into the HUD mode. Also, the mouse, which was recently integrated into Radare 2, was not integrated into HUD mode. So I enabled the mouse usage in the HUD as well. So now after doing this, all the Emacs and VI and mouse and everything now works in HUD mode. So the next slide.
Ravi.
Yeah. My task, the next task that I was, okay, I'll start now. The next task that was the next task that I did was the Radif to graph improvements. So in the current, when I started working on this, the diff graphs were not properly supported in our Radare. The only output format was the X dot. So there were no ASCII art-based graphs for diffing. It was only for normal graphs. So most of the other commands were also not functional. Few of the commands like AGF or something had a lot of output formats, but AGD did not have them. So in this task, I implemented all of those commands. So can we go to the next slide? So as a part of graph improvements within Radare, I implemented quite a few commands that were already implemented for other graph-based commands, that is AG. So here in AGD, I implemented 7 output formats. So the first one is just outputting the R2 commands that were used to construct a particular diff command, and then we have the graphis dot, that was a default output format that was in Radare 2, and then there is graph modeling language, and then JSON, and ASCII art, and then interactive ASCII art. So this was not actually part of my Radare 2 console interface improvements proposal, But since I had to integrate all these commands into Radif2, I just thought that it would be nice to Radare to have this as well. So if we can go to the next slide. Yeah.
Yep, done.
Yeah, so yeah, even Radif2 had only one output format, that was X dot. So since I already implemented all the other diff graph modes for within Radare, I had to just integrate them into Radif2. So it was a simple task. Once I was able to get all the HD commands working, I just had to invoke them within Radif2. So I initially had some problem with how communication was established between Radif2 and Radare 2 in general. So after modifying a couple of lines of code, it was working fine. So after I was done with this, it started supporting all the listed output formats. So the default one is ASCII art. It also supports the GraphViz dot mode, which was the default mode used by Radif. It also supports some other modes like JSON and JSON with disarm and without disarm as well. It will also show you the STB key value pairs that was generated as part of the diff graph construction. This similar to the AZD commands, and it also has tiny ASCII art and interactive ASCII art. So if you get into the interactive ASCII art, most of the visual commands work in here. If you type in the help, that is question mark, you will be able to see the commands that are in visual that can be used in the Radif2 graphs as well, interactive graphs as well. The navigation is very similar to the visual graph mode. You can use tab keys to move between and arrow keys to scroll and stuff like that. So can we go on to the next slide, please?
Yep, you're in the new ASCII art graph.
Yeah, so if you can see in this slide, we have the default version, the X dot output, and the new ASCII graphs as well. Yeah, so look-wise, it is very similar. It highlights different parts of the code with yellow, gray, and red that you cannot see in this current slide, but I was initially planning on showing you a live demo of all the graph commands, but due to some technical difficulties, I'm not able to do that right now. But yeah, this is like the gist of it, the brief look of the two versions. So yeah, if we can go to the next slide.
Yep, you can.
Yeah, so my next task was a UTF-8 based improvements. A lot of commands within Radare 2 were not actually using UTF-8. Instead, they were using normal ASCII characters. So I had to change some code in order to make it work with UTF-8. So as a part of that, I took up my first task to change the colors of the ref lines in the disarm. So initially, all the ref lines in the disarm were of the same color. So there was one issue that was not actually a part of my Radare 2 proposal. So I thought interesting, so I took it up. right now, after I was done, the ref lines were of two colors. The upgoing ref line was of different color, and the down coming ref line was different colors. Can we go to the next slide? So, yeah, in this slide, you can see the different ref lines with different colors. So if it's up, it's showing light blue, and if it's down, it's showing light blue, and if it's up, it's showing dark blue color. So the rest of the functional things like usage of UTF-8 in disarm was preserved in this task. Can we go to the next slide? Yeah.
Yep, UTF-based improvement.
Yeah. So as a part of UTF-8 based improvements, I actually implemented several commands to show ASCII art color bars with the section ranges. So for this, I implemented 4 new commands and then refactored a couple of other commands to use the same method. So here the 4 new commands that I implemented are mentioned. That is OB equals. This is for open files, and DT is for debug traces, and AFL shows you the ASCII color bars function lists, and AFB shows you the ASCII color bars for basic blocks. So this was a minor task as a part of UTF-8. So can we go to the next slide? So if you go to the next slide, we can see the actual output. So the main look and feel of it was already designed by Pancake. So he had implemented a command called is dash. So it was already using the same UI. So I just used the same thing for all the other commands that I implemented. Can we go to the next slide, please?
Yep.
So the next enhancement in UTF-8 was for P equals and P double equals. So in order to display the entropy graph and various other graphs in the print mode, they were using the non-ASCII non-UTF-8 based characters. So I did a couple of things for this. One was to enable the histograph mode, which can be enabled by ser.hist.block. So once enabled, it will show you the histogram graph for both of these commands. So if we go to the next slide, we can see the look of how the new look for these commands is. So if you can see P double dash and P dash, both of them uses UTF-8 based characters to show the graphs. So yeah, can we go to the next slide after histographs?
Yep.
So for if you don't want the histogram based view, we also have UTF-8 based characters used for the same P equals based commands. So you can see here when the hist mode is disabled, the graph looks like in the picture. It uses the UTF-8 based character, but it's not actually a histogram histogram block graph. Okay, the next, yeah. So, yeah, the next task was to implement a table API for Radare. I was not able to do this because of the time constraints, but Pancake took and he worked table API instead of me. It has a lot of cool features. It's still not properly integrated into the Radare 2. It's still there. I'll be working on integration in the future in the coming weeks. So the API that was built by Pancake comes with a special querying language to manipulate the data in the table based on various parameters. We can switch different data, and we can even sort the data. So once we are done with constructing of the table, we can even export that particular table into various formats like CSV, etc. So this was completely done by Pancake in like a couple of days. So yeah, I'll be continuing to work on it once the RSOC is done. Yeah.
I will make a demo on the table API and explain how it works. Okay?
Yeah, okay, that would be great.
Okay. Give me 5 minutes. So this is the source code of the table API. Okay, so this is the API. The table API is inside the rutil library. And this API allows you to create a table. So you basically configure the columns. There is a small example, if you will check in the test suite, about how to use this API. So we can see we create the new object with table new. Then we created new 2 tables specifying the type. The first one is string, second one is number. The reason for that is because when we are sorting tables, or well, we are sorting the rows, we want to basically define the type. So depending on the content, we will sorting different things. The cool thing is that it's not also being able to change that, but also able to change the format. So when we print the size, for example, we can specify that we want to show the units. So it will be showing like megabytes, kilobytes. We want to show a color, for example, if it's not yet implemented. We can have like adding some colors in there also in the table. So when we create the 2 tables with the 2 columns, we add the rows. And after that, we can have a bunch of different API calls, like, for example, sorting or filtering or making a query. The query thing is basically like a textual interface for calling the other APIs, like filter, sort, and whatever, in order to create and filter the contents of the table. In this example, it's basically creating this and then sorting the contents of the table and then printing in JSON format the output of the table. I will make a demo now. So one of the commands that have support for tables is the list of functions. If we do, and we open a file, we analyze the whole binary, and we use AFLT for table, we'll get an output like this. So we see that there is like different columns, one of them containing the address, one containing the size of the function, one the name of the function, number of basic blocks, xrefs, etc. So let's say that we want to filter that. So for example, we want to get all the functions that have more than 1 basic block. So we'll say number of basic blocks greater than 1. And we see that the table is a bit smaller now. Okay? The next thing that we can do is basically specify that we want to sort this by, for example, by the size of the function. So we will say size, sort, incremental. So it will be sorting the rows of this column, of this table, using the size column. And not just this, we can also specify which columns we want to pick. So for example, we want to get only the address and the name, for example. So we'll be taking address and then the name. So here's. Thanks to this table API, I mean, the main problem was some design decisions that we had to take in order to implement this feature. it was to have a way to process all the information that is stored inside R2, like function information, disassembly, listing symbols, listing methods, imports, sections, whatever. So all the things that we have, like, for example, listing sections, you see that the title of the sections is not always aligning depending on the size of the rows and so on. So it's something that you end up like re-implementing many times. Another cool thing of the FLT, the table API, is that you can specify the output. So for example, if you want to get that table filtered as JSON, you just specify the J at the end of the comment. So you can filter that with the indent JSON, so you get an output like this. This means that many things that you can only do with R2Pipe right now by using Python or JavaScript, by processing all the data that you get from JSON, you can basically get it filtered directly from Radar2, which is much faster and simpler. There are more things because the table API allows you to import and export in different formats. So you can import a CSV, for example, and you can export it in JSON, or you can export it in ASCII art or whatever. It's also support for HTML output. Most of the things, so the basic features are working. You saw that this is implemented, but there are still some imports and exports that are not yet implemented. But you can imagine the amount of things that you can do. So you can basically replace Excel with that. So just importing a CSV and then processing the columns, like zooming the amount of values in one column and putting it in another table, etc. So that's the table API. So you can continue with the future work.
Yeah. So apart from all the tasks that we discussed about in this PPT, I also worked on some other minor bug fixes and a few other minor command implementations that were too minor to bring it up in this presentation. So I'll just talk about the future work. So as Pancake mentioned, table API does not use colors or UTF-8. I'm planning on implementing it this week, next week, I mean, the coming week. So, and then work on integrating this table API wherever necessary. So, one of the other important tasks in the command line command interface, the implementation of the tree API, which I'm interested in and will be working on it soon. So apart from this, there were a lot of other minor issues that were in the project. So I thought that they were too minor to be put on this slide, so I didn't put a lot of them on here. So yeah. Can we go to the next slide?
Yeah, we have the questions.
Yeah, questions.
I will ask into the crew if there is any question about these tasks. Yeah, we'll take the microphone there.
Are there any plans for having user-defined shortcuts or key mappings without compiling or recompiling?
Excuse me?
Yeah.
On the command line.
Did you hear your question?
Yeah, sure.
No, I was not able to hear the question.
The question was about if there will be any way to define user-specified key bindings for DEETLINE?
Yes.
For DEETLINE.
Yeah. But you might have to change the source code for this to work. Currently, we don't have any external file from where the key bindings are read. As far as I know, I should confirm with Pancake. Is that the case?
Yeah, right now it's not configurable, but
Yeah.
it's probably something that will be interesting to have at some point. So be able to create like custom key bindings, like control something that spawns a specific command or something like that. That's the idea you had in mind? Yeah. Can you open an issue for that so we keep track of the proposal?
Yeah, I can do that.
Yeah, okay. Any other question? Okay. Thank you.
Thank you. Yeah, also, I want to thank Pancake and XVilka for guiding me through this. They were very helpful and very patient and helped me with most of the tasks that I was able to achieve. So yeah, thanks to them.
Yeah. Thank you for participating in the Radare Summer of Code and also for being able to finish all the tasks that you had assigned. So it was great to mentor you, and it's so sad that you didn't make it. So probably next year maybe or so on, we'll probably be able to meet you in real life. So, and also hope that, because I mean, it seems like you are really enjoying the development of R2, so I guess that you will be sending some more drivers from time to time, or at least contributing.
Yeah.
Okay, so thanks.
Yeah, thank you.
Thank you.